Kia ora and welcome to another Cahoots tool training video. Again, this is not a video that is designed to act as standalone training. This video assumes that you have done the tool training at the Cahoots workshop, and this is a refresher, it's a prompt, it's a reminder of the things that you've learned. So we're going to talk about drills and impact drivers. What's the difference? How are they used? This is a drill. You can identify the drill because it has a chuck at the front. The chuck rotates in order to grab drill bits with the 3 jaws in there. The impact driver, by contrast, has a collet, a spring-loaded collet, which you pull forward to take bits in and out. Pull the collet up, bit goes in, and now it's locked. Pull the collet up, bit comes out. These two tools have a similar anatomy. Let's have a quick look at that. They both have a trigger. They both have a forward and reverse switch. And that's sort of where the similarities end. As I said, the chuck on the drill is where we install bits, with the spring-loaded collet on the driver. The drill also has a speed control up on the top. It has 2 gears, gear 1 and gear 2. And it has a clutch. This ring here with a drill symbol and a series of numbers. We'll explain what that's for in a moment. The impact driver is simpler. It doesn't have any speed control, although some versions do. It has a forward and reverse switch, and it has a trigger. Now, what are they both used for? They have similar uses. A drill is primarily used for drilling holes, obviously, in wood, in metal, in plastics, in all kinds of materials. The impact driver is used primarily for driving screws into materials, and it's particularly used for driving big screws or driving screws that have not had pre-drilled holes. And that's kind of an important distinction, because the drill, which is often marketed as a drill driver and has some features for driving screws, is also used for driving screws. So what is the fundamental difference apart from the slight structural shifts? Well, a drill with its 2 speeds pulls drill bits around. The drill bit goes in the drill, and then as we pull the trigger, the drill turns and we are able to push it through material. The impact driver does the same thing, except that instead of just pulling the driver bit around, it hammers it. It has an internal function. It has little hammers in here which hammer onto a special component, and that hammers the bit around. So if you think of the impact driver as putting a wrench onto the screw and then tapping it around with a hammer, the drill is the equivalent of putting a wrench on the driver bit or the drill and pulling it around with a smooth motion. Why is that important? Well, the forces required to push a screw, and particularly a large screw, through timber without pre-drilling a hole are quite large. With the impact driver, when we drive a screw, because it hits the screw around, we don't have to fight the force of pulling the screw around. So the impact driver doesn't have a tendency to pull my hand around in the opposite direction to driving. If we use the drill to drive with the right bit in it, then the whole force required to twist the screw and force it into the timber is being exerted through the drill to our hand, and the drill has a tendency to pull in the other direction. If it's a big screw, that can be a lot of pulling and twisting and spinning the drill around. And so the impact driver has the advantage that it can drive bigger screws without twisting your hand, and also hitting those screws allows those momentary impulses of energy to be really high, and it can drive much bigger screws. So just quickly, the limitations. There are many different kinds of drill bits. There are many different types of driver bits, but drill bits vary hugely, and it's important to look at the manufacturer's specifications, the manufacturer's suggestions, requirements and instructions for use for the different drill bits. We'll talk about some, but we can't cover all of them. Damaged and blunt drill bits are a problem. They require more force to use. Their damaged bits can break, can shatter, and you're more likely to injure yourself because you're using more force to use them. If they're blunt, we can sharpen them. If they're broken, if they're chipped and cracked, they need to be disposed of. So let's get set up to use these tools. So the drill, mostly used for drilling. Let's set it up for drilling. We need a drill bit. We have a drill. We need to make sure that the chuck is open wide enough to accept the drill bit. And when it is, we can wind the chuck in until it grabs the drill bit. We can keep pulling as hard as we can on this chuck, because that tightens the jaws on the drill bit so it won't slip. And now that drill bit is locked in. there's a lock on these chucks. If you turn back a fraction, you hear that click, it's now unlocked. That's for taking the bit out in the other direction. So we pop it in and we twist, click, 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 click to tighten, and that's locked in, and that drill bit should be gripped tightly and the chuck is locked. Then you need to consider the clutch. We'll talk about what the clutch is for when we come to driving screws, but right now we're going to drill a hole, and so we want the chuck lined up with the little drill symbol. We've also got to consider speed. Speed 1 slows down the drill bit for more control. It gives you more control if you're drilling large holes in timber, gives you more torque, so if you're drilling holes that are in hard material, then you'll go into speed 1. If you're drilling metal at all, you'll always be in speed 1 because you need more torque and you want more control. For timber, we're quite happy to drill in speed 2 a lot of the time, depending on the size of the drill bit. The bigger the drill bit, the slower the speed you want to go. We can also control the speed with the trigger. We don't have to go full on. We can feather the trigger. And the more that I pull, the faster the drill runs. When I let go, the drill is braked, and so it stops suddenly. This is in speed 2, perfect for drilling a block of timber. And then one last thing on the drill is the forward and reverse. That's this slider here. If the slider is pushed to the left, so pushed in with my index finger here, if you're right-handed, then the drill is in forward. It now, if you watch the drill bit, is going to cut a hole. We can run the drill in reverse. Not very useful for drilling. It will not work. That will not make a hole in our piece of work. It will just chew up the surface and it will get very hot. So making sure we're in forward gear, the drill is now ready for use. While we're looking at setup, we'll quickly have a look at the impact driver. It is much easier to set up. We choose the bit that we want, we put the bit in the driver, and then we check our direction, which is the same as the drill. If it's pushed left, that is driving a screw in. If it's pushed right, that is taking a screw out. So, we're not ready to work, we don't have any PPE. Now, drills, small drills like this, they're not very loud. We don't always need hearing protection. We might, depending on what we're drilling, and if we're using a bigger, louder drill, we might. The impact driver doesn't sound any louder when you're running it like this, but when it starts to hammer, it is extremely loud. The moments that it hammers, the bang, 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 are extremely loud, particularly in an enclosed space, and so we definitely need hearing protection for the impact driver. Eye protection is really always something that we should be wearing for most things in the workshop. There is potential for one of the drill bits to break. Drilling itself and driving can cause splintering of screws and timber, and there's potential for those particulates to get into your eyes. Some kinds of drilling can cause excessive dust, and then we need dust extraction as well. And of course, there is the risk of entanglement. Now, my hair is out. If I'm drilling and I'm bending down and maybe I'm putting a lot of force against the drill, you can see we've got a problem already. So, same rules as normal apply. We need to be avoiding loose clothing, we need to be avoiding things like hoodie toggles, and we, in my case, maybe some of your cases, need to wear a hat or something to contain my hair. The final hazard that is always in play with these tools is that drill bits can become very hot when you're drilling. Ideally, they won't become too hot. You don't want them to overheat. They can lose their hardness if they get hot enough. They can burn your timber. We don't really want that. If the drill is sharp, it shouldn't get that hot. Even when you're drilling steel, if the drill is sharp, it should cut nice chips of steel. Even in steel, this shouldn't get too hot. But it can. Driver, on the other hand, or using the drill as a driver, when you put screws into timber, there's a lot of friction, particularly if you haven't pre-drilled a hole. And so these screws will get very hot. The bits won't get particularly hot, but the screws will. And it's not uncommon to put a screw in, maybe realize that you've made some kind of mistake, take the screw out, and then go and grab it, and it'll be hot. Hot enough to burn you, definitely. Finally, a note about work holding. This piece of timber is clamped here. This is nice and solid, we can drill into that. Things that you're drilling should be clamped or otherwise held in place. If you're drilling a hole in a large piece of timber and maybe you are kneeling on that timber, That's not going to move. Small pieces of material are much more likely to move. The drill has enough force easily to move a small piece around. So one of the things that we never do is take a small workpiece, hold it in the hand, and then drill. It's very likely, it's almost certain, that that workpiece is going to get ripped out of your hand, and it's going to damage your hand. It can fly off into you, into somewhere else. It makes the drill unsteady. It's a very bad idea. So what are the key things about actually drilling with the drill? Well, we don't need to force it. We let the drill do the work. There's a lot of muscle memory in terms of making sure that you are drilling vertically if you're trying to drill vertically. That's something that you will understand and learn with time. You can use a speed square or something to check the squareness of your bit and then try to keep it steady. The main thing is a little bit of downward force to make sure that the drill is biting, but we don't need to force it through the material. If you're doing that, you've probably got a dull drill bit. So you probably noticed just with that little bit of drilling is that the drill is pulling itself around. That's called kickback or binding. It's similar to what I described when you're trying to drive a screw with a drill like this. When the torque at the drill bit, the torque that is pushing the drill bit through the timber, is also pushing the drill in the opposite direction. If the drill binds up, it's going to swing around, and it's not uncommon to be drilling in a tight space. The drill binds and the drill bit flings around in this direction, very much towards your face. Now, ways to avoid kickback. We don't want to create an angle between the drill and the hole, so we're trying to drill straight. You can't start drilling a hole and then turn through some angle and continue drilling. Drill bits don't work that way. They don't cut on the side, they only cut on the tip. So once you're into a hole, that's the direction that you're going in. Another is to be prepared for kickback. You can hold the battery component of the drill to prevent that spinning. You can hold that against the torque. Finally, understanding that kickback and binding is a lot more common with some drill bit types than others. These twist drills, what most people think of as standard drill bits, these don't bind particularly often. They can on their entry to a workpiece and on their exit from the back of a workpiece. If you have your workpiece clamped firmly against some waste material, something that you can drill into, then the exit doesn't tend to damage the workpiece as much, and also it restrains the drill bit, and so you don't tend to get that kickback. But particularly drilling through steel, also with timber sometimes, when you get to that exit point on the other side, if there is nothing there, if you're drilling into free space, then it's not uncommon for the drill to bind and kick a little. Now let's look at basic use of the driver. We often use square drive screws and square drive bits to go with the square drive screws. The screws stay on the bit more securely, and when you're driving them, the bit doesn't tend to disengage from the screw as much as can happen with other screws. Phillips screws or posi drive screws, cross-headed screws, often the forces involved with an impact driver will kick the bit out of the screw, and it's hard to maintain that engagement while you're screwing into a surface. One very important thing that I try to teach people is that although the impact driver is forcing the screw around and the screw thread is pulling it into the timber, you need to make sure that the contact between the bit and the screw is very solid. And that means that on impact drivers, you actually need to provide quite a lot of force directly in line with that screw to hold it in the workpiece. So let's drive one of these in. Hearing protection. You can see a common thing happen there when I finished driving that screw. When I came to remove the driver from the screw, the bit was so well engaged and the screw had deformed slightly because there are such forces involved that I had to give it a bit of a tug to get the bit to disengage from the screw. That's fine, it's common. You heard at the end of that driving, the do-do-do-do-do. That is the impact mechanism doing its work and driving that screw around. Now, there is another noise you might hear, and that's the noise of the bits skipping, sliding over the head of the screw and disengaging. It sounds similar but duller. I will try to demonstrate both for you. We do not want this noise to occur because it trashes the screw and it trashes the driver bit. I'll try to do it slowly to make it clear for you. This is the noise we want to hear. This is the mechanism in the driver doing what it's supposed to do. That's a sharp crack, 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 crack. If I deliberately disengage from the screw some, we get a It's a deeper sound, it's a less sharp sound, and you can tell if you're looking at it that the bit is slipping in the head of the screw. If you do that for any length of time, you'll damage the screw severely and you'll start to wear the bit out. They are consumable, they do wear out, but let's try and rein that in. Now, I was talking before about the force required to keep this engaged in the screw for screwing the screw into the material. And that's very important, and the screw is pulling itself away from you, so you're following the screw in with force to maintain that engagement. The same is true when you're taking the screw out. So when you're taking a screw out with an impact driver, there's a sort of counterintuitive process going on. You need to be forcing the driver bit into the screw, but you're trying to take it out. So it feels like you're doing the wrong thing. You're pushing in and the screw's feeding out. Now the screw thread is going to push against you. That's what's pushing the driver back out of the timber. That's a good thing. So we're letting the screw do the work. I'm in reverse and I'm going to start driving out. So the screw is quite warm even though it's only a small screw. So I'm going to drive this in again, and I'm going to get you to listen to the tone of the impact driver. The important thing that I did there is I'm feathering the trigger. This is a really important thing when driving screws with an impact driver. You hear a lot of people pulse the trigger, they give it a squeeze, they give it a squeeze, they give it a squeeze. Those little pulses of movement are much more likely to disengage your driver from your screw. They're much more likely for the screw to pull into the timber, pull away from the driver, break that connection. It's harder for you to maintain that control. So what I tell everyone to do is to place the screw where you want it and then start slowly. The screw will bite. I'm not in a great position for this. And then, as I need more torque, I pull the trigger more. As the screw is no longer going in very far. And for this small screw, I never got to the point that I was pulling the trigger fully. Okay, so we put that screw in and out using the impact driver, which is the best tool for that job. But as I said, the drill is also a functional driver. We can use the same bits, but they don't click into a collet in the same quick release way as they do in the impact driver. These have to be torqued up in the chuck. Now this is a 3-jaw chuck. The shank of these driver bits is hexagonal in cross section, and so 1 jaw on each second face. It will tend to go into that orientation, but just make sure that it's not crooked. This is called run out. If we deliberately mount the bit at an exaggerated angle, or try to, that's not what we want to see. We want to see low run out, so we want to see it running very true to the axis of the drill. This is also something you should check with small drill bits. Large drill bits, they tend to sit nicely. Small drill bits can get crooked in the 3-jaw chuck. So now, there's a screw in there from the impact driver. I've put the drill in reverse. I'm putting it into speed 1. We can engage that bit. And it removes the screw nicely enough. Again, small screws, not a problem at all with the drill. But do be aware, on larger screws or harder materials, that there's that potential for kickback, that potential for that drill to be moved in opposition to the torque required to put the screw into the timber. So we put this drill back into forward, and then we'll have a look at the clutch. What the clutch does is limit the amount of force that the drill will use to turn this screw. The numbers on here are fairly arbitrary. So I've just gone for 10. And now the drill is in forward gear. We'll put the screw into a new hole. And you can hear we've hit a point, and it doesn't sound like the impact driver because remember there are no hammers in here. what's happening is the clutch is slipping. It's designed to do that. The screw isn't all the way in. You can see that the screw's most of the way in, and when the head started to hit the piece of timber, the force required to put it in increased, and the clutch, set to number 10, slipped. So it stops you from putting screws in too far. It stops you from over-tightening screws. And it does actually stop kickback. Now, it limits the drill's torque so much that you can't use it as a kickback prevention feature most of the time. But it is going to prevent that from happening when you're screwing things in like this. That screw didn't go all the way in, so we'll try a higher setting on the clutch. We'll try to go up to 20, which is almost the maximum. We'll re-engage, and then we'll try and we'll see how far the screw goes in. This time it sunk the head of the screw into that piece of timber. Maybe a little further than we wanted, to be honest. And so the clutch is designed to prevent overscrewing. In a lot of applications, it's not a very useful feature, but there are times when you've got consistent timber, or you're mounting jib or something else where the properties are fairly consistent and you want to try to limit the screw depth to the same each time without having to eyeball it, then the clutch can be useful. It's good practice to always turn the clutch back to drill mode, because people are going to pick this up thinking it's a drill. If we don't have it in drill mode, we still have the clutch set to something, we probably won't be able to drill because the clutch slips. If that ever happens, you know that somebody has left the clutch set, so you go all the way around until you're on the drill symbol. There are many different drill bits for a drill. Twist drills we've already talked about. They come in all different sizes. This is a hole saw. The hole saw cuts holes. This is a saw blade. It is very sharp. These hole saws always need to be used with a pilot bit. If you don't have this pilot bit here, then the edge of the saw is going to bind in different ways to the workpiece, and it's going to kick the hole saw around. It's going to gouge the surface of your workpiece. It's often going to fly off, and people can get a lot of injuries on their hands from hole saws without center bits. There are other ways to secure hole saws for drilling holes in certain circumstances, like making sure that you have a piece of timber with the same size hole clamped firmly in place, and then you can slide the hole saw through it. But in most cases, you absolutely have to have the pilot drill. These have a huge cutting area, and they are much more likely to kick back than twist drills. So let's prepare for that. Let's make sure that we're holding the drill to try and prevent kickback. The forces can be very large, especially if you're in first gear with more torque here, which you might need to be to make this cut happen. And there is very little you can do, ultimately, to prevent kickback completely. The solution is to be prepared for it. It can hurt your wrist, it can hurt your hand, the drill can fly around and hit you in the face or somewhere else, and so those are the things to be prepared for. Secure holding, making sure that you're not in the plane where the drill can spin if it does bind. Those are all good ways to avoid injury from kickback. This is a spade bit. These are a relatively cheap and crude way to make larger holes than the drill could normally make. So this is a 25mm drill bit. It'll make a 25mm hole. It tends to make slightly ragged holes that need some cleanup, but it is an option and is often useful. There are all kinds of other drill bits. Make sure to check manufacturer's recommendations. Make sure to ask Kahoot staff if you need to. We can't go into all the drill bits here because there are simply so many. In terms of driver bits for the impact driver, most of them are just like this. They have different shaped or sized heads on, and they click in, and away you go. You can also put an adapter in here, which means you can put a socket wrench on here, and then you can use those sockets to drive machine screws, bolts, take nuts off, things like that. Finally, there are drill bits designed to go into impact drivers. Now, these drill bits are very aggressive. They're typically used for making large, crude holes, and they're often used by electricians for running hole through stud, or plumbers, things like that, where the finish is not super important because it's going to be hidden, but where you need a hole and you want to do it quickly, and you've already got your impact driver handy. One major advantage of these for making larger holes is that because the impact driver has that hammering mechanism to deliver high torque, you don't get kickback with an impact driver. And that means that even though we're drilling a big hole, we're not going to get kickback. So that's a major advantage of using this kind of thing in here. But the main disadvantage is the hole will not be clean and tidy. You can of course use this type of drill bit in the drill, but these are very aggressive drill bits, which means that they're taking a large amount of material out for every turn of the drill. And that means that the risk of kickback with the drill is very large. Basically all the specialist drill bits, things that are not simple twist drills, they all have a higher risk of kickback with the drill than standard twist drills do. So hopefully that reminded you of the things that you covered when you did your drill and impact driver training. Remember, you're always very welcome to ask for refresher training. You're very welcome to ask questions of Kahoot's staff and volunteers who've been approved to train you on these tools. Otherwise, make some cool things.